This is the overview for Module 5 of the 10-week class. In this module, there's only 2 sessions. You can think of it as an opportunity to spend some extra time preparing for the test. You're going to be looking at acid reactions and acid strengths. And so this goes into the 3 types of reactions that are acid-base reactions. You're mostly going to be doing these ones, and you do need to learn it because you're going to need to be able to write these acid reactions later on in the semester. And you're going to write them like that, and you're also going to write them by adding water. And then you'll also, this is kind of like trends, you'll learn like what is a strong oxoacid versus a strong binary acid. Remember, there's really only 6 strong acids, so after you go out of that range, you're just comparing weak acids. So the closer they are to the side, the larger the K. I just want to point out though, like, no weak acids have large Ks. A large K would be like times 10 to the negative 4th, and it can go like times 10 to the negative 30th. So Ks aren't very large for acids, but it's still, it makes it really easy for you to be able to just determine the, which one's strong and which one's weak. It's a real fast kind of a question to get on a test and to answer. And then we're going to be looking at these right here, pH, POH, H3O+, OH. These are all calculations and formulas that all relate to each other. And then also strong acids and strong bases. And I actually left a few of the formulas I intended to put on here out. So here are 2 formulas. So we have relating H3O+ and pH. This comes back to having logs. And then also you can say that 10 to the negative pH is equal to H3O+. And then you can say that 10 to the negative POH is equal to OH minus. And then there's another equation that relates OH and H3O+ to each other. So basically there's 6 equations you'll be using, but they kind of are all related to each other, and you can use them to get from one species to another species. There's actually a chart drawn to show you how you can do all those conversions. And the second part is strong acid, strong base. And it's just a reminder that, like, if you have one OH group in NaOH, then that's how many moles of OH you have. So you can use this as a conversion factor. If you know that the molarity of that is like 2.0 moles per liter, then you can use it to convert from NaOH to just OH. And you might say, well, why would you want to do that? Because you want the pH of something. And same for this one. Oh, I left off one other equation you'll learn. 14 minus pH is equal to POH, and that 14 minus POH is equal to pH. All the equations. And make sure you use the rest of the time to study for test 2.